In our lesson today, we're going to have an introduction to probability, and we're going to focus on simple probabilities. Probability can be written many different ways, but the best way to think about probability is when it's written as a ratio, which is a fraction. The way that we set up the fraction is what we want to happen in the numerator divided by the number of possibilities in the denominator. As a formula, it's going to look something like this. P stands for probability of some event, and it equals the number of ways that the event can occur divided by the number of events that are in the sample space. And that's what we've got outlined here. Probability of an event, the number of items that the event can occur, divided by the number of items in the sample space. Now, your sample space is a list of all the possible outcomes in an event. The total number of outcomes are the amount of items that are in the sample space. And it's important to remember that probabilities are between 0 and 1 inclusive. So you can't have a probability greater than 1. It can't be 1.5 or 2 or 3. Your probability is always going to be some fraction that's in between 0 and 1. And so in our first example, we're going to look at the probability of when we roll a die. When you roll a die, the sample space, which again is your list of all the possible outcomes, your sample space is 1, 2, 3, 4, 5, and 6. Those are all the possible outcomes when you roll a die. The number of items in the sample space is equal to 6. So whenever we find the probability with a die, our denominator is going to be a 6. And so in our first example, it says, what's the probability of getting an even number? Well, if you think about it on a die, 2, 4, and 6 are even numbers. That's 3 out of the 6, which could be simplified down to a probability of 1/2. In part B, they want to know what's the probability of getting a prime number. Okay, well, it's important to remember that a prime number has two factors, 1 and itself. And so we have to look at these numbers and figure out which ones have exactly two factors, themselves and 1. Well, 1 times 1 is 1, so 1 only has one factor. 2, 1 times 2 is 2, so that's two different factors, so that's a prime number. 3, 1 times 3 is 3, that's the only way we can do that, 2 factors, so 3 is prime. To make 4, we can do 1 times 4, but we can also do 2 times 2. So that's 1, 2, and 4. That's 3 factors. We don't call that prime. We call that composite. 5 is 1 times 5, 2 factors, which makes it prime. To make 6, we can do 1 times 6 or 2 times 3. That's 4 different factors, so that's composite as well. So we want the number of prime numbers on a die. Well, there's 1, 2, 3 out of 6. Which can be simplified down to 1/2. In part C, they want to know what's the probability of getting a multiple of 3 on a die. Well, the multiples of 3, that's when you count by 3s, 3, 6, 9, 12, etc. Well, 3 and 6 are multiples of 3 that are on a die. That's 2 out of the 6 possibilities, which makes your probability 1/3. In part D, they wanted to know the probability of getting a number that's smaller than 7, a number less than 7. And if you look at all the possibilities, all of them are less than 7, so that's 6 out of 6, which has a probability equal to 1. This has a special name, which is called a certainty. In part E, they want to know what's the probability of getting a number that's greater than 10. Well, if you look at all your numbers here, none of them are bigger than 10, so that's 0 out of 6, which is equal to 0, and this also has a special name, which is called an impossibility. In the previous two examples, we saw two special probabilities. The first one was called a certainty. Rolling a number less than 7 is called a certainty. A certainty is an event that will always happen. An event that will always happen. When you roll a die, you will always get a number that is less than 7. It's going to happen, so it's called a certainty. In E, it said the probability of getting a number greater than 10. Well, on a die, you can't get a number that's bigger than 10. So that was called an impossibility. An impossibility is an event that will never happen. It will never happen. When you roll a die, you will never get a number that is bigger than 10, as long as that die is a standard die. You'll get 1, 2, 3, 4, 5, or 6. Okay, so looking at this chart here, this lists all of the different probabilities. They range between 0, which is an impossibility, from 1 to a certainty. The closer that probability is to 0, we call that event unlikely. The more likely, or the higher that probability is, if it's greater than a half, we call that a likely probability. Okay, so again, it's important to remember that probabilities range between 0 and 1. The closer the value is to 0, the less likely it is that that event will occur. The closer that the value is to 1, the more likely it is that the event will occur. One more thing that we can talk about, to find the probability of the wording not, when the word not is in the event, it can be found by subtracting the straight probability from 1. For example, what's the probability when you roll a die that you will not get a 4? Okay, well, we know that there are 6 possibilities on a die, which is equal to 1, 6 out of 6. And we know that if we can get a 4 on a die, well, there's only one way that can happen. There's only one 4 out of the 6 possibilities on the die. So to find that probability, it would be 6 out of 6 minus 1 out of 6, which is equal to 5 out of 6. And that makes sense because there are 5 different numbers on a die that are not a 4. Okay, so the probability of not getting a 4 on a die is equal to 5/6. With simple probability, besides dice, another common thing that gets used a lot is a deck of cards. And so it's important for us to know what is in a deck of cards. And when we have a deck of cards, we have 4 different suits right here. Okay, this one here is called clubs. This one is hearts. This one is diamonds. And this one over here is called spades. Clubs, hearts, diamonds, and spades. And so let's write those in for our suits. Clubs, hearts, diamonds, and spades. Okay, and I've actually got some cards right here. These are the aces in all of those suits. Okay, and if you look at the colors, notice that there's red cards and there are black cards. If you look at the suits, we can see that the clubs and the spades are the black suits, the hearts and the diamonds are the red suits. So I can put a B for black, red for R for red, R for red on diamonds, and B for black on spades. So it's helpful to know what colors those are. Okay, and those are the aces. There are cards that are called face cards. Those are self-explanatory. Those are the cards that have a face on them. And the ones that have a face on them, I've got listed up here. It's the jack, the queen, and the king. Ace is there, but again, if you look at the ace here, well, there's no face on that card, so the ace is not a face card. The only face cards would be the king, the queen, and the jack. Okay, so again, ace is equal to the value of 1 and is not a face card. The total number of cards in the deck. There are 52 cards in the deck. So when we're doing probabilities with a deck of cards, the denominator is always going to be 52. The total number in every suit. Well, if there's 52 cards and there's 4 total suits, that means that there's going to be 13 cards in every suit. So each one of these suits has 13 cards. There's 13 clubs, 13 hearts, 13 diamonds, and 13 spades. And the sample space for each suit, okay, the cards range, they start at 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are your number cards. And then each suit also has a jack, a queen, a king, and an ace. And if you count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's how we get the number 13 cards in every suit. Okay, so underneath we're going to answer some probabilities based off of a deck of cards. In letter G, they want to know, what's the probability if you were to pick a card at random that card would be a heart? And so we know for our cards, there's 52 cards in a deck. And we just said that the sample space for each suit is these 13 cards right here. There are 13 cards in every suit. Hearts is a suit, so there's 13 out of the 52 cards that would be a heart. 13 out of 52 simplifies down to 1/4. 1/4 of the deck are hearts. In letter H, they want to know what's the probability of drawing a face card. Well, again, if we review back up here, the face cards are the king, the queens, and the jacks. All of these suits have a king, a queen, and a jack. So there's 4 kings, 4 queens, 4 jacks. That's going to be 12 total cards, 12 out of 52. 12 out of 52. That simplifies down to a probability of 3 out of 13. In example K, they want to know what's the probability of drawing a red card. Well, again, we know that's out of 52 total cards. And if we remember back up here, the red suits were the hearts and the diamonds. The hearts and the diamonds. Well, remember that each suit has 13 cards. There's 13 diamonds and 13 hearts. That makes 26 total red cards. 26 out of 52, which simplifies down to 1/2. Half of the deck is red. In letter M, it says, what's the probability of drawing the 5 of spades? Well, again, every suit has these cards right here. So every suit has a 5, but only one of the suits is the spades. So there's only one card out of the 52 that's a 5 of spades. In this example, they want the probability of drawing a card that is a non-face card. Well, we know there's 52 total cards in the deck. And in this example, we knew that there were 12 face cards out of the 52. So if I subtract those 12 away from the 52, that means 40 of the cards are non-face cards. 40 out of 52 simplifies down to 10/13. I can divide each of those numbers by 4. In letter I, they want to know what's the probability of getting a red king. Okay, well again, hearts and diamonds are red. And both of them have a king. There's a king of hearts and a king of diamonds. So that's 2 out of the 52 cards, which I could simplify down to 1 out of 26. In letter J, what's the probability of drawing a 2 or a 3? All of the suits have a 2, and all of the suits have a 3. So there's 4 2s and 4 3s. That's a total of 8 out of the 52 cards. 8 out of 52 simplifies down to 2/13. You can divide both of those numbers by 4. In this example, they want the probability of getting a black card. Well, in this example, we knew that for the red cards, 26 out of 52, or half of the deck, is red. And it's the same thing with the black cards. 26 out of the 52 cards are black cards, which is the other half of the deck. Half of the deck is red, the other half is black. In letter N, they want the probability of getting an even number. So again, it's out of 52. And again, every suit has a 2, 4, 6, 8, and 10. 1, 2, 3, 4, 5 even numbers. And there's 4 suits. So 5 times 4 means that there's 20 even numbers in your deck. 20 out of 52. I can divide both of these numbers by 4. And that gives me a probability of 5/13 when I simplify. Finally, in letter P, they want to know what's the probability of getting a red face card. Again, the face cards are the king, the queen, and the jack, but we want them to be red this time, which would be the hearts and the diamonds. So there's 2 red kings, 2 red queens, 2 red jacks, which is 6 out of the 52 cards. And if you were to divide both of those numbers by 2, since they're both even, that's going to give you a simplified probability of 3 out of 26.